today I would like to give you the most updated information that coming from the paper we just published this month here, right here. So if you are interested in the topic, then you can see the title, and it's going to be published very soon in Nutrition in 2020. Okay. So the topic of the paper is high protein supplementation facilitate weight training induced bone mineralization in baseball players. Okay, and from the paper you are going to learn several very important conclusions. Before I get into the topic, let me just show you one picture here. Okay, can you see this? They are astronauts, so they are going to space. So this is the space station. It's going to a space, okay? And can you see this? This is a treadmill, right? And you can see there is a string here is pulling this person down. Okay. You can see this. You can see this, right? So what is the reason you want to have exercise and you have the bondage to push you down? Why this is the case for astronauts? You know what happens if you go to space? Gravity, right? The gravity is very low, right? So when you don't have gravity, then the physical stress, the mechanical stress on the bone disappears. And what happens is the bone loss quickly. Okay, so you are going to have the bone loss. So what do you learn from this? Okay, so what do you learn from this? If you go to the space and the bone mass is reduced, is significantly reduced, so what do you learn from this? So let me just give you a very important background here. Okay, you can see a precipitous decline in aerial BMD with loss greater than 10% detected in hip, right here, and spine in some astronaut following a typical 6 months mission in space. Okay, so what do you learn from here? It's very simple. You have already learned the muscle information is the driver for muscle hypertrophy, right? So the same principle applied to the bone, right? So when you challenge muscle, the muscle is going to have damage, right? Some damage, especially for the weaker cells. It's going to die, right? And that will trigger muscle inflammation. And we found that if you block the muscle inflammation, the muscle will not grow, right? So that gives you the evidence that the damage is able to trigger inflammation, and the inflammation is the driver for growth, right? And now you see bone again, right? And remember that in the morning when you get off the bed, you start to have the gravity to push your bone, right? So your bone is undergone challenge, right? And therefore the bone size is maintained, right? But if you go to the space, the mechanical stress disappears. Then you lose that kind of challenge, and therefore the information will no longer exist. And then you start to have the bone loss, okay? So it's not zero gravity, we call microgravity because the gravity is just too small. So people sometimes call the zero gravity for a long time. And this phenomena is quite similar to inactivity. So if the patient go to hospital and lie on the bed, the bone is also reduce their mechanical stress. And that is also cause the bone loss. Okay? And a lot of aged people, when they cannot move, they use the wheelchair, they also have the same situation. So this, to understand the nature of this phenomenon is quite important, and is transferable. The knowledge is transferable to the physical inactivity induced bone loss. Okay, and also you can learn from the astronaut experience, and people, it's very easy to conclude that the compressive mechanical stress is important for bone growth. Okay, so if you go to the space, you are removing the gravity, and the gravity is causing the compression of the bone, right? And therefore compression is very important stress for bone growth, right? So that's what people used to think, right? So according to this phenomena, there's a reasonable hypothesis is engaging in weight-bearing and compressive-based resistant exercise on regular basis should improve the aerial bone mineral density. BMD is called bone mineral density. Okay, what kind of the mineral in bone? What is the most important, most abundant mineral in bone? Yes, calcium. Good. Yeah. There are some others, but calcium is most important. Right? Okay. Before you get into the data we have, you also want to know some important background. Is what is the lifespan of bone cells? You understand that mechanical stress is imposed on the bone all the time when you are standing, right? And you are walking, when you are exercising. Mechanical stress is imposed on the bone, right? And you understand that bone cells are dying and regenerating, right? So the bone is actually dynamically remodeling and by a fast cell turnover rate. So you want to understand what is the half-life, what is the longevity of the cell. It's somewhere around 2 weeks to 3 months. So that gives you the knowledge again. The cell in human body are mostly short-lived, right? So you should regard human body as a society of living cells. Okay, this is very important background for you. So you can expect that if you dramatically change the mechanical stress, the daily mechanical stress on your bone for more than 3 months, then the bone shape can change, right? It's like everybody's face. If you smile every day, 3 months later, your face is going to change, right? So that is very similar things. So you want to understand that the cell in human body is dynamically changed by cell death and cell regrowth. And that changes is closely related to the local challenge, right? Okay, so the resource is going to the places, the carbon source and the nitrogen source from your diet is going to the places that require for cell regeneration. Okay, let's go back to the topic about bone. What is the gold standard to measure bone density? Well, the gold standard is just take out the bone and measure on the scale. That is the gold standard. But we cannot do it in human, right? So what is the alternative standard that people would trust? Is this. This is considered the most acceptable measure for bone density. Is DEXA, right? So how many of you have used the DEXA here? Raise your hand. It's more than 50%, so you know what DEXA is, right? Okay. So that is the gold standard to measure the bone density. Okay. Okay. Then, right now I would like to bring you the question. Does mechanical compression increase areal, A means areal, bone mineral density? Well, why put A is because A means areal, means the gram square. Okay, this is square, okay? So that gives you areal bone mineral density. Okay. So when you see the data of the bone mineral density, you see that the unit is gram per square centimeter. So that is what we call areal bone mineral density. Okay. So you all experienced the DEXA, and you all know that what A, B, and B means. Okay. Then another question is, does mechanical stretching also increase the area of bone mineral density? So from the experience of astronaut going to space, you understand the compression, mechanical compression, is the strength imposed on bone, and that causes the bone can maintain their size, right? How about stretching? Do you think stretching can also increase bone mineral density?
Maybe yes, like eccentric contraction in muscle.
You are probably correct, and the evidence is support your answer. I just give you the data later. Okay, how do you demonstrate that? Okay, let's look at here. Okay, before we get into the answer, okay, this is the right-handed picture, right? I think most of you already learned, you may already played baseball before, right? So when you throw the ball, right? What happens is you are swinging your arm, and the arm starts to stretch, right? Especially at the moment that you are swinging, right? And that is not compressive mechanical stress, right? Compressive means like this. You push the ball, right? That is compressive. But stretching is opposing direction. It's different direction. So when you throw the ball, then the bone starts to stretch, right? And what do you see? Okay, this is the right-handed picture. And do you see any difference between the right and the left in color? Any difference? Where? Which location? Left and right. Are they balanced in color? Here and here. Obviously, it's lighter on the right hand, especially in this area, right? Here. But you don't see much here, right? You don't see much. But this is very, very obvious, right? And this person is the same, right? Different, right? They are different. They are different, right? How about leg? No difference, right? So what do you learn from here? You throw the ball, it has no effect on your leg, right? No effect. But it has the effect on the bone that has suffered the challenge. Right? So this is what we learn. And they are baseball players. They have the experience of the baseball training for more than 5 years. So this is long-term. Remodeling causes the asymmetry in bone mineral density across the arm. Right? So this is right-handed. How about left-handed? Look at the left-handed. So they are actually top 8 team in Taiwan, 世新大学, 世新 University. They are top 8 in baseball. 甲 A 的. So you can see the left-handed is on different direction. Here, 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 right? So it's big difference between left against the right, right? So this is something that you want to understand, that the stretch can also increase bone mineral density in a way very similar to eccentric muscle contraction, right? So not only the compressive type. And is that important for you to coach? If you have the people requires the bone rehabilitation, or they want to strengthen their bone mineral density, and they look for help from you. And most of people think that the only compressive type is important. But here you learn that the stretch is also important. What kind of exercise can stretch the bone? Just give me some example.
throwing, kicking.
Okay, that's good. Kicking. How about you push, you hang yourself? That could also be, right? What else? Many types. You are very smart. You can just give some example, and you are experienced, right? Okay, so from here you can just design a lot of things just for that kind of purpose. Okay. Then another question: do all bones have similar increase in aerial bone mineral density after 12 weeks bone weight training? So that is, we gave the weight training for 12 weeks. Okay. So if you just do weight training, upper body and lower body, okay, and what happened to the whole body bone mineral density? Can you give me the answer? Let me just reformulate the question. Whole body BMD. So if you do upper body and lower body weight training, then what happened to the whole body BMD? Increase, decrease, or no change? Yes, actually it's decreased. Decreased, not increased, okay? I'll show you the data later, okay? And also another fact is, another important background for you. The protein makes up roughly 50% of the volume of bone and 1/3 of its mass. Okay, so we used to know that the muscle has a lot of protein, right? But actually bone also has a lot of protein. Okay, so protein are important for bone formation. What kind of protein is the most important in bone? What kind of protein? Collagen. That's the correct answer. Collagen is the most important protein in bone. Okay. Okay. Then you, based on that fact, you ask another question. Does dietary protein content matters for weight training induced increase in BMD? When you do weight training and you give the protein, high protein and low protein, does it matter for the change in bone mineral density? Okay, so you have all these questions. Just let me show you again. Question 1. Does all bone have similar increase in BMD after weight training? We asked about, to be more specific, the whole body BMD. Okay, so I show you the data later. The second question, does dietary protein content matters for weight training induced increases in bone mineral density? show you the data here. The first question, when you do training, upper body and lower body, okay? And what happened to the whole body bone mineral density? Whole body right here, okay? This is low protein. Whole body minus 1.5%. High protein minus 0.8%. So if you just look at the high protein group and the low protein group, you don't see statistical significance. But if you pull this together, then you found that the main effect is significant. So it gives you the conclusion that if you do weight training, the whole body BND is actually dropped a little bit. And this is not the only study. I also found another study show the same thing at different age. Okay. Okay. But if you look at the humerus bone is right here. This is humerus bone. You remember that baseball player has the humerus bone that is different in BMD, right? Okay. Then you see that you have pre and post. Humerus bone. This is non-dominant arm. Okay, non-dominant arm, that means you don't challenge the bone daily during training, right? So let's look at the non-dominant bone. Increased by 2.7%. Okay, so if I'm the baseball player and I'm the right-handed and I measure my left hand, which is not challenged all the time. And when I do the weight training, the bone mineral density increase. Okay, so the question again, do all bone have similar increase in bone mineral density after weight training? No. The whole body is dropped a little bit, but the challenge site has the increase in bone mineral density. So that gives you the idea that local response is very important, right? How about the right hand that you already challenge all the time? Does it matter when you do weight training? You have the stretching, right? When you throw the ball, you have the stretch on the bone, and therefore the bone mineral density is already very high, right? And now you do in the weight training, you are compressing stress. It's also given to the same bone. How about your right hand? Increase or decrease? This is local response, right? Okay. If you look at the dominant arm before and after, no change, no significant change. So it's not 2.3%. It's far from 2.3%, right? So that gives you the idea that if your bone is already had high mineral density, it's getting more difficult to get further increase, right? But at low protein condition, low protein at 14% is the recommended value for everybody, right? Okay, but if you give 44%, then it's different. Okay, if you look at 44%, then you see even the dominant arm has relatively higher bone mineral density than still get increased in humerus bone, right? So under normal dietary condition, you do weight training, the bone mineral density will increase only to the site that has first. Has low bone mineral density and untrained, right? Okay, and as I just mentioned, the training protocol here is upper body and lower body, right? Okay, then upper body and lower body limb, which one has higher bone mineral density under normal condition? Here and here, where has higher BMD?
Lower.
Very good. Yeah, if you look at here, you can clearly see the answer, right? Lower body has a lot of places that has the high density bone, right? Particularly where? Here. So you understand when you are standing, this region has a lot of mechanical stress. And also here, here, and here, right? But if you look at the upper body, that is small amount of the bone mineral, especially the arm, right? Not much. So make a guess. If I do the upper body and lower body weight training, compressive type of the weight training, which part is going to increase more?
Upper.
Exactly. So if you look at the evidence, it's quite clear. If you look at the leg, right? Low protein, no difference. No difference. High protein and low protein. The lower body, even you are compressed, give the compressive mechanical stress. No difference. Okay. For leg, no difference. No difference. Right? Before, after, minus 0.7, minus 0.7. And this is also minus 0.7. This is plus 0.7. So that gives you the idea that if you do upper body weight training and lower body weight training, the lower body doesn't get increased in BMD. And the places that get increased is the bone that already had low BMD. Right? Okay, then come back to the main question of the lecture. Can weight training increase BMD? Yes.
所以老师，如果我们要增加全身的 BMD，就应该全身性一起练，是不是就可以达到增加？因为他刚才拆开，等于说，如果我只有四肢在受到压力，我的脊柱完全没有受到压力，所以它减少可能是我脊柱。那万一我是做深蹲的话，是不是可能我脊柱有受到压力，我腿有受到压力，再搭配一些四肢会更好？
Okay, he is laying out the question that, okay, I understand that this is a local response. What if I challenge the entire body? Every single bone of your body got challenged, right? Can you increase bone mineral density for the entire body? What is the answer? Okay.
And no evidence.
Sounds reasonable, right? But the evidence already clear, right? It's quite clear. The increased bone mineral density only happened in challenged bone. That's one thing. And in contrast, slightly decreased whole body bone mineral distribution. Right, so you have upper body got challenged, you have lower body got challenged. But the bone mineral density, the resource appears to go only into the site that has low bone mineral density. So you have redistribution phenomena here. Okay. You have the redistribution. Okay, so that's why we want to consider the human body as a society of living cells. They are not only collaborating to each other, but they are also competing when they have the challenge, right? So collaboration and competition is continuously going on in the same society, right? So if you regard human body as a society, it would be more, much easier to understand the phenomenon. Oh. And we also learn stretch exercise is very effective to gain bone mineral density. So that is another thing we have learned from here. Right? And just by answering his question, bone with high mineral are less likely increased by weight training. So if you have already had a very high bone mineral density, even you challenge, you don't get increase, right? And if you have the neighbor that has already had a low BMD, the mineral is going to that direction. So because you have redistribution phenomena going on, right? But do you have the solution? Yes, the solution is high protein. If you provide high protein, you can also promote the increase for those born with the high mineral, right? So the solution here is just giving to high protein. Then you can resolve the question he asked. Okay, so the most important conclusion is that the nutrient, either carbon source or nitrogen source, goes to where it's challenged, causing damage and inflammation.